Okay, continuing on today with our Laplace transform playlist, I wanted to do another example of a Laplace transform using the unit step function. We have here the Laplace transform of minus 4t squared plus 48t minus 144 times the unit step function at 6. Okay, in a previous video, we found this formula that we have here down at the bottom, and we can use this for a Laplace transform of the unit step function we have here and some function shifted by the same c value that we have on the unit step function. And this is a pretty useful formula because if we can just get it in this form where we have our shifted f of t minus c, then we can just find the Laplace transform of f of t, and that's going to give us our big f of s value. So to make this all work, what we're going to need to do is just focus on this. This is going to be our f of t minus c, and in this case the c value is going to be just 6 because that's what we have on the unit step function. So what we need is this to be f of t minus 6, and so we're going to need to just manipulate this to simplify it. So to start with this, what I'm going to do is we're just going to factor it, and I can definitely take a 4 out, and I think I'll take a minus 4 out. So let's see what happens when I factor out minus 4. We get t squared minus 12t, and then this becomes plus 36. But then this here is a perfect square, so we'll have our minus 4 in front. I can actually write this as t minus 6 all squared. But that's perfect because now we have this as a function shifted by 6. So from this, we can write our f of t value as minus 4t squared. And so before we get back to this formula, we just want to find the Laplace transform of f of t. So that's going to be the Laplace transform of minus 4t squared. And what we can do is we can always factor a constant value out front of the Laplace transform. So we'll have a minus 4 in front, and then we're going to have the Laplace transform of t squared. Now, in the previous video, we found a formula for the Laplace transform of t to the n, and we found it to be gamma function n plus 1 over s n plus 1. But what we'll do in this case, because we have an integer exponent, I can write this in terms of factorial, so I can actually write this as n factorial over s to the n plus 1. So using that here, we'll have our minus 4 in front. Our n value is 2. 2 factorial is just going to be 2. And then we're going to have s, 2 plus 1, or s cubed. Minus 4 times 2 gives me minus 8 over s cubed. And we'll use that for, this is going to be our f of s value. So putting this all together, we'll come down here to our formula and we'll use this. We have our f of s value right here, so we can write this as minus 8 over s cubed. And then we're going to have here e, our c value is 6, we're going to have minus 6s, and that's it. Okay, that's it. Good example with the unit step function. Thanks everyone for watching. Have a good day.